Hello everyone. So today we are going to see further injection molding. But before that, let us see some revision which we have seen last time. Last time we have seen the processing of polymers, polymer processing. It has two types which we have seen: thermoplasting, thermosetting, and also we have seen the different types of plastic manufacturing process. Then out of that we have seen two plastic manufacturing process. First one, that is compression molding, and also its advantages, disadvantages, applications. Second one, that is transfer molding. We have seen by using a transfer molding how the plastic is manufactured. Okay. Also apart from this, we have seen the advantages, disadvantages, and application of transfer molding. Now, today we are going to see the next molding, that is nothing but the injection molding. So here you can see the injection molding. So this injection molding is a manufacturing process for producing the parts by injecting the material into a mold. Okay. So injection molding can be performed with the host of materials including metals, glasses, elastomers, compressions, and most commonly thermoplastic and thermosetting polymers. Okay. So here normally what happens that we'll see the step by step, but after a product is designed, usually by an design engineer or by an engineer, molds are made. Whatever the molds are there, these molds are made by a mold maker or tool maker from metal. And the material which normally uses for this are either steel or aluminum, and it is having a precision machined to form the desired part. Okay, so if we see there are different parts are there. Okay, so that is hopper is there. We had hopper, the powder pellets are there, and also here the cylinder is there, and in this cylinder the piston is there, and the cylinder is surrounded by the heaters over here, and here the injection chamber is there. Further, here the nozzle is there, screw is here, and here the cavity is there where the molded part is made, vent is there, and ejectors are there, and the whole the set of mold is there. So this injection molding, whatever the injection molding is there, this injection molding is widely used for manufacturing the variety of parts from the small component to entire panel of cars also. Okay, and if we see the material of the part is feed into a heated barrel, mixed and forced into a mold cavity where it cools and hardens to the configuration of the cavity. Okay, now let us see the steps over here. So first step, that is, here you can see in hopper whatever the granulated or powder thermosetting plastic is feed into the hopper. Whatever the powder or granules are there, that is fed into the hopper. Okay, so after this, if we see the injection molding, it consists of a cylinder, then it further contains a piston. Many times what happens, at some places piston is there, and at some places screw is there. Okay, rotating screw is there. Okay, so what happens, whatever the screw is there, by rotating the screw, this material is allowed to flow in horizontal direction. It can be pushed in this direction, and in some cases the piston are there. The piston is initial position is here. After feeding the material again, it is pushed over here. Okay, so here if we see further, this cylinder, or sometimes it is the barrel, this cylinder is surrounded by the heater over here. Okay, so whatever the piston is there, this piston is forced so as water the forced the melted plastic at the end of the cylinder. Okay, and once enough plastic has collected at a hydraulic ram, it pushes the piston or screw forward, injecting the plastic through a screw into the mold cavity. Okay, so initially what happens, the piston or screw position kept over here, and after feeding the sufficient material, it is pushed into the again into the mold direction. Okay, so here what happens, due to the heater, whatever the plastic granules or whatever their material is there, it get injected into a mold through a nozzle and sprue. Okay, so the mold is warmed, whatever the mold is there, the mold is warmed before injecting, and the plastic is injected quickly into the mold to prevent it from hardening before the mold is full. Okay, so here the pressure is maintained for a short time to prevent the material creeping back or during hardening. Okay, so this prevents the shrinkage and allows, therefore, giving a better quality product. Okay, so the molding which is left to cool before injecting from the mold. Okay, whatever the molding is there, the molding is left to cool over here before injection. Okay, so here the molding, what it does, it takes the shape of a mold cavity. So here you can see, in such a way the plastic products are manufactured by using a injection molding. How these granules are injected into the mold cavity, and the cylinder is or barrel is surrounded by the heater where it heats the plastic granules over here, and after that this is injected through a nozzle into mold cavity, and after that it is kept over here. After hardening, this part is injected. Okay, in such a way the plastic is prepared. Here you can see the actual machine. Here the control panel is there, here the mold is there, and here the hopper is there where the material is fitted over here by clamping over the platform. And if you see further, here the hydraulic fluid and piston mechanism is there for injection cycle. And here further they have used the rotating screw in this region. So as material, whatever the plastic granules are there, it is fitted in the hopper, and due to this mechanism, these are pushed in this direction. Whatever the granules are there, it is pushed over here, and here you can see further many times here rotary screw is there. It pushes the material in this direction over here, and here whatever the barrel is there, this barrel or cylinder, it is surrounded by the heater over here, and again it is feeded into the mold over here, so that you will get the required part, plastic part. Okay, here again it is given. Okay, the process is given. Advantage: by using the injection molding, the production rate increases, and by using the injection molding, we get a small part which is having a close tolerances, and also whatever the wastage of material is there, it is less in injection molding, and the complex geometry shapes can be manufactured or produced by the injection molding. And if we see over here, in injection molding, whatever the tooling cost is there, whatever the mold is there, its cost is high, and setup cost of injection molding is also high. And the further the disadvantage is that whatever the undercuts are there, that undercuts can't be manufactured or produced by the injection molding. And the applications are household application, electronics and automotive dashboards, buckets. These are the applications of injection molding. Okay, so this is what the injection molding, parts which produces. Okay, so here the cost of this mold is high in this injection molding. Okay, now next, that is nothing but a extrusion molding. Okay, so extrusion molding, here the extrusion of plastic is a high volume manufacturing process in which raw plastic material is melted and formed into a continuous profile. Okay, so the extrusion process this extrusion produces, if you see, it produces items which is in continuous, such as pipes, strips, fans, deck railing, window frames, plastic frames, sheet, thermoplastic coating, wire insulation. Even the one of the example that as you have seen the use anthroplastic paint. So that is also manufactured by using this extrusion molding process. Okay. So here the process is quite similar to the injection molding. Okay. So here what happens in the extrusion of lasting, whatever the raw plastic material is there, those material in the form of noodles. Okay. Also it is called as small beads. Okay. So that is feed into the hopper. Okay. Which is mounted on the top portion. So due to the gravity, what happens? These plastic pellets comes into about the in this barrel, enters into the barrel. Okay. So apart from these, the additives such as colorants and UV inhibitors are used and can be mixed into these plastic pellets prior to arriving at the hopper. Okay. Or some additives are added. The process has much in common with a injection molding from the point of the extruder technology. Okay. Though it differs in that it is usually a continuous process. Okay. So so it can offer many similar profiles in continuous length. As we know, the pipe, whatever the pipes or tube are there, they are continuous. Okay, there is no break is there. So continuous pipe is manufactured, and after that, they do the pieces in some standard length. Okay, so those pipes can be manufactured by using your extrusion molding. Okay, so the here what happens, the material enters through a feed throat, which is known as, which is having some opening in the barrel, and comes into contact with the screw. This rotating screw, which is having runs at 120 rpm, it forces the plastic pellets. Okay, it forces the plastic pellets forward into the barrel, which is heated to the desired melt temperature of the molten plastic, which having the range of 200 degrees Celsius to 275 degrees Celsius, but it normally depends on the polymer. Okay, so such happens in extrusion molding. So in most process, a heating profile is set for the barrel. Okay, in which three or more independent PID control heaters are there, heater zones, which gradually increases the temperature of the barrel over here. Okay, so this allows the plastic pellets to melt gradually as they are pushed through the barrels and lower the risk of overheating, which may cause degradation in the polymer. That's why they are using with a PID controlled. Okay, so whatever the extra heat is there, extra heat is contributed by the intense pressure and friction taking place inside the barrel. In fact, if an extrusion line is running certain materials the fast enough, the heater can be shut off and the melt temperature can be maintained by pressure. And friction alone inside the barrel, it can be maintained. Okay, in most extruders, whatever the cooling fans are there, cooling fans are present to maintain the temperature. Okay, if uses, that is if the heat is generated too much at that time, they use a cooling fan to maintain temperature. Okay, so if forced air cooling proves insufficient, then in cast in heater jackets are employed, and they generally use a closed loop for distilled water. Suppose if it is not able to control by a cooling fan, so these are provided with a closed loop of water in heat exchange with tower, or the water is provided over here to maintain the temperature. So at the front of the barrel, the molten plastic leaves the screw and travels through a screen to remove any contaminants in the melt. Okay, the screens are reinforced by a breaker plate, okay, which is having a thick metal with many holes drilled through it. Okay, so which serves to create a back pressure in the barrel for uniform melting and proper mixing of the polymer. Okay, so it also we can say that it does the function of converting a rotational memory of molten plastic into the longitudinal memory. Okay, so after passing through the breaker, it is not shown over in this diagram, but breaker is over here. Okay, so after passing through the breaker plate, molten plastic enters the die. This is the die shaping die. Which shape we want, that die is used over here. So it enters the die. The die is that which gives the final product its profile and must be designed so that the molten plastic evenly flows from a cylindrical profile to the product's profile shape. Okay, so this is what about a extrusion molding. So as we have seen this information, now let us see the advantages. Advantages of extrusion molding is high production volumes. Okay, because it is continuous process. That's why the production volume is high. Next, that is it is having a low cost compared to other molding process. Next, the design flexibility is there, short lead time is there, and here the whatever the coating of wire is there, it can be achieved with desired properties. And last, that is continuous parts can be produced. And the disadvantage is that it is limited for a complexity of parts. Suppose if your parts is complex, then you can't use the extrusion molding. And one more disadvantage is that only uniform cross section having the parts can be produced by using a extrusion molding. Suppose if the cross section is not uniform, at that time you can't use the extrusion molding. This is the limitation of the extrusion molding process. Now let us see the next, that is the application. Application, that is the extrusion molding is used to produce the parts. So where those parts used, that is for manufacturing rods, plates, tubes, wire, cable coating, hose liners, hose mandrels, filaments, sheet, multi-layer film, medical packaging, food packaging, where the continuous shape is there. Okay, so I one more previously I told you the pen that can be used by using this extrusion molding. Okay, so these are what about the extrusion molding process. Now next, that is the blow molding. Okay, so here you can see the diagram of blow molding. Here barrel is given at the bottom, grouping is there. So this blow molding is a manufacturing process by which hollow plastic parts hollow plastic parts are formed. Here, the blow molding process begins with melting down the plastic and forming it into a heated hollow thermoplastic tube. Okay, so whatever the tube is there here, this is like this is also known as thermoplastic tube. It also called as a parison. The parison, whatever here, the parison is there. The parison is a tube like a piece of a plastic with a hole in one end okay, with a hole in one end and through which compressed air can pass. Through which a compressed air can pass. Okay. The air pressure then pushes the plastic out. Pushes the plastic out. We'll see also at all step, but initially just to understand. So this air pressure pushes the plastic out to match the mold. Once the plastic has cooled and hardened, the mold opens. You can see the mold opens and the part is injected. Okay, so here the material which uses for blow moldings are having a low density, that is low density polyethylene, high density polyethylene, polypropylene, polyvinyl chloride, polyvinyl terephthalate. These are the material which uses in a blow molding. Okay, so here whatever the disposable containers of having various sizes and shapes, drums, recyclable bottles, automotive fuel tanks, storage tanks, globe light fixtures, toys, small boats are produced by using a blow molding method. Okay, so let us see the the steps of a blow molding. Okay, so here the step one, that is the parison is there. This parison is extruded vertically in downward direction between two mold halves. This first mold house, second mold house. Okay, so when the parison reaches the desired length, when this parison reaches the required length, the two mold halves are closed. You can see over here, resulting in pinching the top of parison and the sealing the blow pin at the bottom. So here pinching is done, and at the here end, here the pinching is there. Okay, sealing the blow pin in the bottom of the parison end. So here the parison is inflated. Whatever the parison is there, this parison is inflated and through a air which comes from a blow pin. Okay, so parison is inflated by a air which blown through the blow pin, taking a shape conforming that of the mold cavity. Then the parison is then cut off. Parison is then cut on the top. Okay, so the mold cools down and the halves opens and the final part is removed. In such a way, the part is manufactured by using a blow molding. If we see, there are also different blow moldings are there, that is extrusion blow molding, injection blow molding, stretch blow molding. So this is what about the blow molding. Here you can see also arrows is there, molten plastic, parison is there. Okay, so here the material is inserted, the parison is there, it pushes the air. So here it, the parison takes the shape of a mold. So you will get a molded part over here. This is the description about a blow molding. Advantages, the advantage is that low tooling cost, production rate is fast, and also its ability to mold a complex part with uniform thickness. Scrap generated are less, and large hollow shape can be produced in blow molding. And whatever the produced parts are, those produced parts can be recycled by using a blow molding. Now the disadvantage is that the blow molding is limited only for a hollow parts. So this is first limitation. Second limitation is that thick parts can't be manufactured by using a blow molding. Okay, and the applications of blow molding, that is the bottles in different shapes, size, jars, containers, ducting, fluid oil tanks, mugs, and toys. Such parts can be produced by a blow molding. Okay, this is also blown extrusion. This is one of the plastic manufacturing method. Okay, so you have seen this air bubble and take a shape. Okay, here you can see air bubble is there. By pushing the air bubble, whatever the plastic is there, is get inflated, and through the roller you will get a sheet of a plastic in such a way. Okay, then thermoforming is there. Okay, so thermoforming we'll see in next lecture. So today we are going to stop for here. Thank you.